Hi, welcome once again to online lecture of B.Sc. Analytical Chemistry third year. In last we have learned about the reference electrode, what is meant by reference electrode, and uh, there are how many types of the reference electrode. That is, there are three types of generally reference electrode used, and they are the standard hydrogen electrode. Second one is a calomel electrode, and third one is the silver chloride electrode. So let's see how this reference, what is the use of this reference electrode and their what is their construction and working of that electrode, and how these are used in the potentiometric EMF measurements. Thanks. So let's begin with the these type of the electrodes. So friends, the reference electrode is nothing but a potentiometric electrochemical cell. One half cell provides a known reference potential, and the potential of the other half cell indicates the analyte's concentration. By convention, the reference electrode is the anode, and thus the shorthand notation for the potentiometric electrochemical cell is reference separated by means of the double vertical line indicator. This double vertical line is nothing but the salt bridge, and the self of potential is E cell is equal to V indicator minus E reference plus EJ. So the ideal reference electrode provides a stable known potential, so that any change in the E cell is attributed to analyte effect of the potential of the indicated electrode. In addition, the ideal reference electrode should be easy to make and to use. Three common reference electrodes are known, that is the standard hydrogen electrode, calomel electrode, and silver chloride electrode. So see, the first one is the standard hydrogen electrode. Although we are rarely use the such types of the standard hydrogen electrode for the routine analytical work, it is the reference electrode used to establish standard state potential for the other half reaction. So the SHE consists of a platinum electrode immersed in the solution, in which the activity of the ion is 1 and fugacity, that is hydrogen ion, is 1 and fugacity is 1. So a conventional salt bridge connects the SHE to indicator half cell. The shorthand notation for the standard hydrogen electrode is PT solid, H2 gas having fugacity 1 separated by a single line, H plus solution is aqueous and having the activity 1 separated by means of salt bridge, and the standard state potential for the reaction is, by the definition, that is 0.0 volt at a temperature. Despite its importance as the fundamental reference electrode against which we measure all the other potentials, the standard hydrogen electrode is rarely used because it's difficult to prepare and inconvenient to use. So the overall, how would see this systematic diagram of the showing the standard hydrogen electrode. See here, the hydrogen is passed through the hood of this. This is the H2 gas is passed having fugacity 1, and see, the H2 gas is passed through this hood of the, which is this platinum wire is immersed into this solution of the H2 H plus, and having the solution of activity 1 and fugacity 1, and this is what joined by means of the salt bridge. So this is what the systematic diagram of the hydrogen, and by using this standard hydrogen one can determine the potential of the other indicator electrode by connecting this with coupling with the hydrogen electrode, standard hydrogen electrode, and the reaction occur is what the H plus 1 electron gives half H2 gas. So the potential is 0 for that, and it is inconvenient to use due to what difficult of the preparation. So the hydrogen electrode and is shown in the above, and the next one is the calomel electrode. So calomel electrode are what the mercury chloride electrode, that is calomel reference electrode, are based on the following redox couple between Hg2Cl2 and Hg. Calomel is a common name of the compound, that's Hg2Cl2. So Hg2Cl2 solid plus 2 electron gives 2Hg liquid plus 2Cl minus aqueous, for which the Nernst equation is E is equal to E naught Hg2Cl2 oblique Hg minus 0.05916 divided by 2 log of activity of Cl minus ion square, so is equal to plus 0.268 volt minus 0.05916 divided by 2 electrons, because here 2 electrons taking part in reaction, so log of the activity of Cl minus ion square. So the potential of the calomel electrode therefore is determined by the activity of Cl minus in equilibrium with the Hg and Hg2Cl2 as shown in the figure. Here was standard saturated calomel electrode is Ce is the concentration of Cl minus is determined by the solubility of KCl. The electrode consists of an inner tube packed with the paste of Hg, Hg2Cl2 and KCl situated within a second tube containing a saturated solution of KCl. A small hole connects the two tubes and porous wicks serves as the salt bridge to the solution in which the saturated calomel electrode is immersed. A stopper in the outer tube provides an opening for the adding additional saturated KCl. The shorthand notation for this cell is Hg liquid separated by means of the Hg2Cl2 single line, that is solid, KCl aqueous saturated and separated by means of the salt bridge. So entire arrangement, entire the construction of the calomel electrode is shown in the below figure. Even in the below figure, see how this calomel electrode looks like. Here what in the here the first tube is what filled by means of the paste of Hg2Cl2 and Hg, and here the saturated KCl is there. Here the mercury paste is there, and here some crystals of the KCl is there, and here one hole is to here what the saturated KCl is there. Then such type of arrangement is used in the preparation of the standard calomel electrode. So the saturated calomel electrode and standard calomel electrode, see one again how this calomel reference electrode is common name, that is what Ag2Cl2 is known as the calomel, and the calomel reference electrode are based on the following redox couple between Ag2Cl2 and Ag. Ag2Cl2 solid plus 2 electron gives 2Ag liquid plus 2Cl minus aqueous, for which the Nernst equation is E is equal to E naught HgCl2 or Hg minus 0.05916 divided by 2 log of concentration of Cl minus ion, nothing but activity of concentration of Cl minus ion square, is equal to plus 0.268 volt minus 0.05916 divided by 2 log of activity of Cl minus ion square. So the potential of the calomel electrode therefore is determined by the activity of Cl minus in equilibrium with Hg and Ag2Cl2, as shown in the figure. In saturated calomel electrode, the concentration of Cl minus is determined by the solubility of KCl. The electrode consists of an inner tube packed with a paste of Hg, Ag2Cl2, KCl, situated within the second tube containing a saturated solution of KCl. A small hole connects the two tubes and porous wicks serves as a salt bridge to the solution in which the Sc is immersed. A stopper in the outer tube provides an opening for the additional saturated KCl. The shorthand notation for the cell is Hg liquid separated by means of single line, Hg2Cl2 solid, KCl aqueous saturated and separated by means of the salt bridge. So because of the concentration of Cl minus ion is fixed by the solubility of KCl, the potential of the saturated calomel electrode remains constant even if though lose some of the solution to evaporation. A significant disadvantage of saturated calomel electrode is that the solubility of KCl is sensitive to a change in the temperature. At higher temperature, the solubility of KCl increases and the electrode potential decreases. For example, the potential of the saturated calomel electrode is plus 0.2444 volt at 25 degrees Celsius and 0.2376 volt at 35 degrees Celsius. The potential of calomel electrode containing an saturated solution of KCl is less temperature dependent, but its potential changes if the concentration and the activity of Cl minus increases due to the evaporation. So this is about the calomel electrode. What the potential is dependent upon the temperature. As the temperature increases, potential decreases for the calomel electrode due to change in the concentration of the ion. So this is about the calomel electrode. Next one is the silver chloride electrode. Other common reference electrode is a silver chloride electrode, which is based on the following redox couple between AgCl and Ag. AgCl solid plus 1 electron gives Ag solid plus Cl minus aqueous. As the case for the calomel electrode, the activity of Cl minus determines the potential of the AgCl electrode. Thus the E of the cell is equal to E naught AgCl Ag minus 0.05916 log ACl, because the reaction the electron number of electron taken part in the reaction is 1, so it is 0.05916 log ACl minus is equal to plus 0.2223 volt minus 0.05916 log of ACl. When prepared using the standard solution of KCl, the potential of AgCl electrode is plus 0.197 volt at 25 degrees Celsius, and another among the AgCl electrode uses the solution of 3.5 molar KCl and has potential is about plus 0.205 volt at 25 degrees Celsius. A typical AgCl electrode is shown in the figure. So it consists of the silver wire and the end of which is coated with the thin film of AgCl and immersed in the solution containing desired concentration of KCl. A porous plug serves as the salt bridge, and the electron shorthand notation of this AgCl electrode is the given as see here what the Ag solid separated by means of the single line AgCl solid, comma KCl aqueous having activity 1, that is X activity, separated by means of the salt bridge. So AgCl solid having AgCl liquid AgCl electrode having the arrangement, see simple what the it consists of a silver wire and the end of which is coated with the thin film of AgCl immersed in the solution containing the desired concentration of KCl, that is 3.5 molar. A porous plug serves as the salt bridge and the electrode is shorthand is like this. This is a porous plug, the KCl solution, Ag wire coated with AgCl, Ag wire, and to the potentiometer it is joined to the potentiometer. So this is about the reference electrode. If you have any queries regarding the topic, that is 3 reference electrode, that is calomel electrode, standard hydrogen electrode, and silver chloride electrode, please put your questions in the YouTube comment box. I will try to answer. In next lecture we are going to learn about the indicator electrode and the ion selective electrode. So if you have any queries regarding this topic, please put your questions in the YouTube comment box. I will try to answer. Thank you. Thanks a lot. Have a nice day.